Hello everyone, I'm Paul Marsh and I'll be walking you through our poster today. We build wireless sensor systems, specifically pH, like what's demonstrated in Figure 1. We've demonstrated a significant portion of the electronics and comms already, and now we're on to improving the sensors. So, the issues with our probes are that these iridium oxide probes have some variation in their calibration upon initial fabrication, and they have some drift in their potential and performance over time. Most of this is up to surface chemistry. But what we want to do is we want to try and control that surface chemistry with some potentiostatic operations. So what this means is that, for example, we would take an iridium oxide probe that we had built, we would hold it at 200 millivolts versus some reference electrode and counter electrode in an electrolyte for a certain amount of time, and when we do that, we would expect the surface chemistry to change the end groups and the redox states. This is one example where we start with some fabrication variability. We have a set of two good probes where the sensitivity is almost the same. They have some offset in their standard potential, and a third probe has some pretty severe initial drift. So if we run that potentiostatic operation, that 200 millivolts for 180 seconds, we get this anodic or oxidative current that spikes and then tends towards zero, at least on some probes, and we end up with a batch of probes that is very, very close now in terms of its sensitivity and its standard potential. Of course, this does not always work. This is an example of when it hasn't. So we check a probe on, let's say, day 13 of use. We run a cal 2 times, and what we find we come back to the probe on day 15 is that the probe is not really operational anymore. Now we have this pretty severe drift. But if we allow it to just rest for another 2 days, we come back and we have a usable probe. So the previous slide tells us the operation can work for grouping our calibrations very tightly and also possibly extending the life of the probes, but we find that it doesn't always work. So we just want to highlight that these are initial results. We don't consider this full proof of process, but there is value in it in that if we get it to work, we can extend the life of the probes and do this operation remotely. And then therefore we can remedy this standard potential drift and sensitivity loss. Now, with future work, of course, we're going to try and optimize this operation. We really need to investigate the surface processes, which we're beginning to do, and of course, investigate consistency. Thank you for your time. If you are curious about any of the more specific details, you can, of course, check the poster for references and further information, and ask me. Thanks.